On May 15th of this year, at 3 minutes past 5 in the morning Pacific time, a spacecraft about the size of a delivery van passed within 4,609 kilometers of the surface of Mars, roughly the width of the continental United States, traveling 12,328 miles an hour, fast enough to cross that same continental distance in under 14 minutes. It did not slow down. It did not stop to study Mars for its own sake. It used the planet the way an accountant uses a legal loophole, perfectly above board, entirely free, and gone before most people noticed it happened. Here is the detail that should bother you. The place that spacecraft is actually headed has been described for nearly a decade now, using one specific number, repeated by outlets that pride themselves on getting things right, and that number is very likely wrong. Not from a rounding error, but from a mistake in the picture sitting underneath it. Here is the number. In 2017, the scientist who leads this mission calculated that if you could gather the metal inside the target asteroid, an object called 16 Psyche, and sell it at the market price of iron, nickel, gold, and platinum, the total would come to something like 10,000 quadrillion dollars, a 1 followed by 19 zeros. The combined output of every economy on Earth, every good and service produced by every country in a year, runs on the order of $100 trillion. Do the division and the asteroid is worth, on paper, somewhere between 70 and 100,000 times what the entire planet produces in 12 months, depending on which year's economic figures you use for the comparison. People read numbers like that and reach the only reasonable conclusion available to them. Somewhere past Mars there floats an unclaimed fortune made of exactly the metals that back every currency and frame every skyscraper on Earth, waiting for whoever develops the nerve to go get it. That is not a foolish belief. It is the correct response to the information as it was handed to people. It is also wrong in a way the scientist who produced the number has spent years trying to walk back. I want to show you exactly where that belief breaks, not the hand-waving version. Well, it's complicated. There's no rocket big enough. But the specific piece of reasoning that gives way, the exact gear that strips. And the spacecraft that just skimmed past Mars 2 months ago turns out to be the instrument that will eventually answer the deeper question underneath all of this, because everything it tested at Mars in May is precisely what it will use on the real target in 3 years. Before I show you the failure, though, I need you to understand something about the object at the center of it, because most of what gets said about Psyche treats it like a settled fact rather than a hypothesis still very much in play. 16 Psyche is a lump of rock and metal about 226 kilometers across. Irregular, more potato than sphere, roughly the length of Massachusetts if you laid it end to end. It orbits the Sun in the main asteroid belt, out past Mars, once every 5 years or so. And it is strange for one specific reason. The overwhelming majority of large asteroids we have ever examined are made of rock, or ice, or some mixture of the two. Only a small handful of known asteroids reflect radar the way a metal object would, and Psyche is the largest of them by a wide margin. A surface that behaves, electrically, as if a large fraction of it is bare, iron, and nickel, the same alloy that shows up in meteorites that started their lives as the cores of shattered baby planets. That single property, a metallic surface on a body this large and this reachable, is what makes Psyche worth an entire dedicated mission. It is also the property that let a market price calculation happen at all, because you cannot price the metal content of something until you have reason to believe there is metal content to price. Psyche itself has been known to astronomers since 1852, when the Italian astronomer Annibale de Gasparis spotted it from Naples and gave it, almost as an afterthought, the name of the Greek goddess of the soul. For more than a century afterward, it was just one dim point of light among thousands of catalogued asteroids, distinguished from its neighbors only by a spectrum that looked unusually flat and featureless when astronomers finally pointed infrared instruments at it in the 20th century. The signature that eventually got it classified as an M-type, metal-dominated asteroid, one of perhaps 9 large. Examples known in the entire belt. What actually convinced anyone that metal-dominated meant something close to solid metal was a measurement called radar albedo. Bounce a radio signal off an object, and metal reflects it far more efficiently than rock or ice does, brighter in radar than almost anything else out there. Psyche's radar albedo turned out to be roughly triple that of an ordinary rocky asteroid. That is a real, hard measurement, not a guess, and it is the actual evidence behind every claim that this particular potato-shaped rock is unusually rich in metal. The mistake was never in that measurement. The mistake was in what people assumed had to follow from it. So the first belief people needed, before they could ever get to a dollar figure, was a story about where a metal object that size would even come from. And the story scientists settled on is genuinely remarkable. So let me give it to you properly before I take it apart. In the first 10 million years of the solar system, while the sun was still assembling itself, small bodies called planetesimals were forming and melting, heated by their own radioactive decay and by the violence of their own collisions. Melt a rocky body enough, and it does something almost embarrassingly simple. The iron sinks. Not metaphorically. Actual liquid metal, denser than melted rock, falls toward the center under gravity, the same way a coin sinks through water, while the lighter silicate rock rises around it. Every terrestrial planet you can name did this. Earth did it. Mars did it. The result is always the same. A metal heart wrapped in a rock shell. And the rock shell is what you actually see when you look at the planet from outside, which raises an obvious question. And it's the question that made Psyche interesting to planetary scientists decades before it was interesting to anyone doing arithmetic with metal prices. If every rocky planet separates into a metal core and a rock shell, and the shell is always what you see from the outside, then how, in the entire history of the solar system, would you ever get to look at a core directly? The answer scientists proposed is violent and specific. In that same crowded first 10 million years, before orbits settled down, these small differentiated bodies were smashing into each other constantly, at speeds high enough to strip a shell clean off without destroying the core underneath. A hit-and-run collision, in the technical language. The kind of glancing blow that shears the soft rock mantle away and leaves the dense metal heart intact, tumbling on through space with nothing left covering it. Psyche, under this hypothesis, is not a lump of metal that happened to form that way. It is the leftover heart of a small world that lost a fight before it ever got the chance to grow up. That whole category. Asteroid did not exist as a concept until an accident forced it into existence. On the first night of the 19th century, January 1st, 1801, an astronomer named Giuseppe Piazzi was working through a star catalog at an observatory in Palermo when he found an object that moved against the background stars from one night to the next. Astronomers of the time had a mathematical rule, since discredited, that predicted a missing planet in the gap between Mars and Jupiter, and Piazzi assumed, reasonably, that he had found it. He had not. Within a few years, 3 more objects turned up orbiting in roughly the same gap, and none of them behaved like a respectable planet. They were too small, there were too many of them, and they kept multiplying every time anyone looked harder. Astronomers eventually had to admit that the missing planet had never existed. What existed instead was a swarm, an entire population of leftover pieces, and they needed an entirely new word for it. That is the actual, recorded first response of trained scientists to genuinely new data about that part of the solar system. Not confirmation of the story they expected, but the quiet, repeated collapse of it into something they hadn't had a category for yet. Keep that pattern in your head, because it is about to happen again, this time to the word metal. Here is where the $10,000 quadrillion number actually starts to come apart, and it has nothing to do with economics yet. It's a problem with the physical picture underneath the price tag. To calculate what an asteroid is worth, you first need to know what it weighs. And to know what it weighs, you need 2 separate measurements: how big it is and how much mass is packed into that size. Astronomers get the size from a handful of independent methods that all have to agree with each other. Bouncing radar off the surface and timing the echo, watching Psyche pass in front of a distant star and timing exactly how long the star blinks out, and imaging the object directly with adaptive optics telescopes that correct for the blur of Earth's own atmosphere. All 3 methods now converge on dimensions of roughly 279 by 232 by 189 kilometers. That part is solid. The mass is harder. It comes from watching how Psyche's gravity very slightly tugs on the orbits of other bodies that pass near it, a tug too small to feel, but not too small to measure over years of careful tracking. Combine the mass with the volume, and you get density, and density is where the story stops behaving. An iron-nickel meteorite that has fallen to Earth and that you could hold in your hand runs about 7.5 grams per cubic centimeter. Dense enough that a chunk the size of a soccer ball would be too heavy for one person to lift. If Psyche really were a solid ball of that same alloy, its overall density should land somewhere close to that number. It does not. The best current measurements, combining radar, occultation, and adaptive optics data, put Psyche's bulk density at somewhere between 3.5 and 4 grams per cubic centimeter, roughly half of what solid metal demands, and closer to the density of ordinary rock than to iron. That is not a small discrepancy you can explain away with measurement error bars. That is the asteroid coming in at about half its expected weight for its size, which leaves exactly 2 honest explanations, and modern planetary science has spent the last several years arguing over which one is true, because the honest answer is that nobody yet knows for certain. There's a second, independent way to check this, and it matters because good science never trusts a single measurement when it can help it. Point a telescope tuned to millimeter wavelengths at Psyche instead of radio wavelengths, and you're measuring thermal emissivity. Essentially, how efficiently the surface radiates away the heat it absorbed from sunlight, which depends on how tightly packed the material is at a microscopic scale. Loosely packed, cracked material behaves very differently, thermally, than a smooth, solid surface does. The emissivity measurements taken so far land in a range consistent with a surface that is at least half metal by weight, but only if that surface also carries something close to 40 to 60% empty pore space. 2 completely different techniques, radar and thermal emission, keep landing on the same uncomfortable answer. Whatever Psyche is, it is not smooth and it is not solid. The first explanation says Psyche really is mostly metal, the way the collision hypothesis predicts, but riddled with empty space. Cracks, voids, loosely packed rubble. Somewhere between 30 and 50% of its interior might simply be nothing, gaps left over from that ancient violence and never fully sealed shut by its own weak gravity. Under this picture, Psyche is still, in a meaningful sense, an exposed planetary core, just a shattered, aerated one, more like a sponge of metal than a smooth ingot. The second explanation is more unsettling for the whole premise. Maybe Psyche was never a solid core at all. Maybe it formed as a genuine mixture, metal and rock mixed together throughout, the way certain rare meteorite types called stony irons already are, and it simply never differentiated cleanly in the first place. Under that picture, the entire origin story, proud metal heart, violently stripped of its shell, is the wrong story, and Psyche is something far stranger. A body that kept its metal and rock jumbled together for 4.5 billion years, defying the very process that built every planet we live on. One of those 2 pictures is closer to true. Nobody currently knows which, and that uncertainty is not a footnote. It is a real part of the reason NASA is sending a spacecraft there instead of just trusting the math. It is worth pausing on how strange it is that we can debate the internal structure of a body 400 million kilometers away at all, when we have never directly seen the inside of the planet under your own feet either. In 1936, a Danish seismologist named Inge Lehmann was studying earthquake waves that had traveled straight through the body of the Earth and come out the other side, and she noticed something that didn't fit the accepted model of the time, which assumed the entire core was a single liquid ball. Some of the seismic waves were arriving faster than they should have, as if they had bounced off a boundary that wasn't supposed to exist. Lehmann worked out that the waves were reflecting off the surface of a solid inner core, floating inside the liquid outer core like a stone inside a bowl of soup. A structure nobody had measured directly, inferred entirely from the bending and timing of vibrations that had traveled thousands of kilometers through rock and metal no human being will ever touch. That is still, to this day, the only way we know anything about Earth's own core. Not a sample, not a photograph. A shadow, cast in earthquake waves, of something we accept exists purely because the mathematics of how it would bend a wave matches what the instruments recorded. Keep that in mind, because it is about to matter enormously. Every method humanity has ever used to learn about a planetary core, including Earth's own, is indirect. We infer, we model, we match a prediction against a measurement taken from somewhere else, and we never once put an instrument directly against the material itself. That is precisely why, if Psyche really is an exposed metal core, however cracked and porous, it would be one of the only objects of its kind reachable by a spacecraft anywhere in the solar system. A place where the theory of planetary cores stops being a shadow cast in seismic waves and becomes something you can point a camera and a spectrometer at directly. And that is also exactly why the spacecraft could not afford to get its instruments wrong when it finally arrives in the summer of 2029, which is the entire reason it spent an afternoon in May of this year, of all things, staring at Mars. Here is what actually happened during that pass. The spacecraft carries 3 science instruments built specifically to answer the metal or not question once it reaches its real target. A multispectral imager, essentially a pair of cameras tuned to see color differences invisible to the human eye. A gamma ray and neutron spectrometer, which reads the elemental fingerprint of a surface by watching how it responds to a constant bombardment of cosmic rays. And a magnetometer, sensitive enough to detect the faint, frozen ghost of a magnetic field a body might have generated billions of years ago, back when it was still molten. None of these instruments had ever been tested against a real planetary body in flight. Mars, which has been mapped down to the meter by 3 generations of orbiters and landers, was the perfect answer key. A body whose true composition is already known well enough that engineers could grade their own instrument's performance against a target where they could check their work. The grading went well. Over the course of the flyby, the imager captured a month-long sequence of Mars swelling from a thin, backlit crescent into a full sunlit disk and shrinking away again, sharp enough to pick out the double-ringed Huygens crater, the wind-blown craters of the southern highlands, and the vast gash of the Valles Marineris Canyon system. It even caught the 2 Martian moons, Phobos and Deimos, as faint points of light. A direct rehearsal for the exact search the mission will run for undiscovered moonlets once it reaches Psyche. Mars's own gravity did its job too, bending the spacecraft's path by about 1 degree relative to the Sun and handing it a boost of roughly 1,000 miles an hour, close to the numbers engineers had calculated years in advance. They confirmed that boost not by feel, but by pitch. Tracking the exact frequency of the spacecraft's radio signal as it climbed back toward Earth, since a signal shifts in a measurable, predictable way depending on precisely how much speed the spacecraft just picked up. The same Doppler effect that changes the pitch of a passing ambulance siren. Every instrument came back reporting exactly what a well-studied planet in front of it should have produced. The mission's own scientists said afterward that they hadn't expected new discoveries about Mars itself. The planet is simply too well known for that. But that was never really the point of stopping there. Which brings us back to the number, because I still owe you the mechanical explanation for exactly why it fails, and the person best positioned to explain that failure is the same scientist who calculated it in the first place. The $10,000 quadrillion figure was never announced as a serious economic forecast. It came out of a 2017 conversation in which Lindy Elkins Tanton, the planetary scientist leading the mission, was asked a hypothetical, and she did the arithmetic honestly, because that is what scientists do when you hand them a question with a real numerical answer. She multiplied the estimated iron and nickel content of Psyche by the going market price of those metals and got a genuinely enormous figure. Reporters picked it up immediately, because a number that large is irresistible, and it traveled through headline after headline for most of a decade, almost always stripped of the caveats she attached to it every single time she said it out loud. There is currently no technology capable of moving an object that size back to Earth, and even the smaller task of mining and processing metal in place, in deep space, with no atmosphere and no existing industrial base, remains entirely theoretical. And this is the part that actually dissolves the number rather than just complicating it. If that much iron, nickel, and platinum somehow did arrive on Earth all at once, the markets that currently set the price of those metals would not calmly absorb the shock. Prices exist because supply is limited relative to demand. Flood the market with 100,000 years' worth of global metal production overnight, and the price of that metal does not stay fixed while the quantity changes. It collapses, potentially all the way towards zero, for the simple reason that a currency stops being valuable the moment anyone can produce an unlimited amount of it. That is the actual gear that strips, and it's worth naming precisely because it's more interesting than, well, that's a lot of money. The 10,000 quadrillion-dollar figure was calculated by holding price constant while imagining an unimaginable change in supply, which is exactly backward, because price is not a property of a substance. It is a relationship between scarcity and want. You cannot multiply an effectively infinite quantity of anything by its current market price and get a meaningful number. For the same reason, you cannot multiply the number of grains of sand on Earth by the price of sand at your local hardware store and conclude that all the sand on the planet is worth more than every human economy combined. The math is correct. The physics represented by that math has already broken by the time you finish the multiplication, because the moment that much material existed on the market, there would no longer be a market for it to exist in. I want to be honest about something in all of this that still unsettles me, and it isn't the comfortable kind of not knowing where you shrug and say science is an ongoing process. In 2021, a team, including an undergraduate researcher at the University of Arizona, ran the numbers again and proposed that Psyche might not be a stripped planetary core at all, cracked or otherwise, that the density mismatch could instead mean it's a genuine rubble pile, a loosely bound aggregate of both metal and rock that never went through violent stripping in the first place, closer in spirit to the asteroid Bennu than to any planet's leftover heart. That paper does not sit comfortably next to the collision hypothesis I just spent several minutes building for you, and both cannot be fully true. What unsettles me is this: a mission that has cost NASA roughly $1 billion to build, launch, and fly, 6 years in transit, its entire scientific justification resting on the idea that this object is one of the only reachable samples of a planetary core anywhere in the solar system, is currently flying toward a target where a real, published, peer-reviewed possibility exists that there is no core there to find. Not a wrong number, a wrong object. The scientists running this mission know that. They have said so publicly, in careful academic language, and they are going anyway, because the only way to actually resolve which picture is correct is to stop calculating from 400 million kilometers away and go look. There's an even sharper version of this problem that most coverage of the mission never mentions. A separate line of modeling looked at how quickly a body of Psyche's size should cool down, and found that holding 40% of your interior open as empty pore space for 4.5 billion years is not thermally easy. Rock and metal at high temperature behave almost like a very slow-moving liquid, and given enough heat and enough time, gravity should quietly squeeze those pores shut long before the present day, the same way old snowpack compresses into dense glacial ice over centuries. For Psyche's porosity to have survived intact, the body would have needed to cool below a specific threshold temperature before the violent collisions that created the porosity in the first place, and the timing required for that to actually work is uncomfortably tight. Not impossible, but tight enough that some of the researchers modeling it have said plainly the numbers are hard to make fit together, cleanly. So even the porous metal core explanation, the more conservative of the two competing pictures, is carrying its own internal contradiction that nobody has fully resolved either. And that, when you sit with it, turns out to be a far larger problem than one asteroid's identity crisis. Consider what it would actually take to check either hypothesis by drilling into a planet you already stand on. The deepest hole humanity has ever bored into the Earth is the Kola super-deep borehole, drilled by Soviet engineers starting in the 1970s, reaching a final depth of just over 12 kilometers before the rock itself got too hot and too plastic to drill through any further. Earth's radius, center to surface, is about 6,371 kilometers. Our deepest hole, humanity's single furthest reach into its own planet, covers less than 0.2% of the distance to the center. We have never drilled through the crust. We have never touched the mantle. We have certainly never touched the core, and by any engineering timeline anyone takes seriously, we never will. Which means that every rocky world we know anything about, Mercury, Venus, Earth, Mars, and every large moon built the same way, carries a core we understand only the way Inge Lehmann understood Earth's, as a shadow in indirect measurements, a shape implied by how waves bend and fields wobble, never once confirmed by direct contact. Take Mercury as the clearest example, because it makes the same point Lehmann's earthquake waves made, using an entirely different kind of shadow. When NASA's Messenger spacecraft mapped Mercury's gravity field in the early 2010s, the numbers implied something that didn't fit the standard picture of how small rocky planets are built. An iron core so large it takes up something like 85% of the planet's radius, far bigger proportionally than Earth's own core, wrapped in a rocky shell only a few hundred kilometers thick. Nobody drilled to check. Nobody could. The conclusion came entirely from how the spacecraft's own radio signal wobbled as it passed overhead, a wobble caused by tiny variations in gravity that only makes sense if an enormous mass of dense metal is sitting close to the surface. That is the entire pattern, repeated on every rocky world we have ever studied closely. Infer the core, never touch it. Psyche, if the collision hypothesis holds even in its cracked, porous, imperfect form, would be one of the very few exceptions to that rule anywhere we can currently reach. A planetary core with the rest of the planet missing, sitting in vacuum, close enough and slow enough and metal enough for an actual spacecraft to actually orbit it and actually measure it directly. That is not a treasure chest. That is closer to finding one exposed page of a book that every other copy in existence keeps permanently sealed shut, a page that happens to describe the one chapter. How planets get their metal hearts, that we have needed and been unable to read directly since the very first person wondered why a compass needle points north, which is exactly why the afternoon inn may mattered as much as it did, small and procedural as it looked from the outside. An instrument that misreads Mars, a world we already understand in exhaustive detail, cannot be trusted to correctly read the one object in the solar system we most need it to get right. Every gamma ray counted, every degree of magnetic sensitivity confirmed, every crater sharply resolved in that time lapse of a shrinking Martian crescent was a rehearsal for a performance with no second take. The spacecraft is now past Mars, on a straight run toward the main asteroid belt, due to arrive at 16 Psyche in the summer of 2029, where it will spend roughly 2 years in progressively tighter orbits, descending, eventually, to within about 47 miles of the surface, doing with real data what a decade of ground-based telescopes and careful arguments could only approximate from hundreds of millions of kilometers away. When that data comes back, one of two things will be true, and either answer is worth more than the number that made headlines for the better part of a decade. If Psyche turns out to be a shattered, aerated fragment of an honest-to-goodness planetary core, humanity will have, for the first time in its existence, direct physical measurements of the material that sits at the center of every rocky world it has ever stood on, including this one. Not modeled, not inferred from a wave bouncing off a boundary nobody has seen, but measured. If it turns out instead to be an undifferentiated rubble pile that never separated into metal and rock at all, that will be, in its own way, just as valuable, because it will mean planetary formation took a path nobody had fully accounted for. And every model of how rocky worlds get built will need to be revised to explain an object that broke the rule the rest of the solar system apparently follows. There is no outcome in which the mission returns having learned nothing. There is only the outcome where the fortune hunters go home disappointed, because there was never a fortune to find. There was only ever a fact, sitting 400 million kilometers away, waiting for an instrument precise enough to read it. So the next time you see the headline calling Psyche a 10,000 quadrillion dollar asteroid, understand what that number actually reveals. And it isn't what the headline thinks it's revealing. It isn't proof of an unclaimed fortune. It's proof of how easily a mind will reach for a price the moment it's handed something it can't yet picture, because pricing a thing feels like understanding it, and it is not, and it never was. Nobody has ever gotten rich from a fact. People get rich from objects they can own, ship, and spend, and a 400 million kilometer sponge of iron and rock, whatever it turns out to be, can be none of those things. It can only be known, which means every article calling it worth more than the planet's entire economy has the value backward. The number was never the point, and the metal was never the treasure. The treasure, if that word even still applies, is the one page of the one book that no rocky world in the solar system, including the one currently holding you up, has ever let anyone read directly. And in 3 years, for the first time since the Earth had a crust to keep its own secrets sealed, something built by human hands is finally going to turn that page.